So, it's nice to be after somebody who explains what can be done when you can see inside the traffic. This is kind of an interesting topic. More you listen to cases, there's a lot of very nice tools, very nice implementations how you can detect information if you can see it. Nowadays, if you think about how much of your applications that you use over browser are non-encrypted, can you imagine any slide where you go that it's not HTTP? How's it going? So, and a lot of cases when you listen into this is that, well, it's nice, but if you cannot see it, you cannot detect it, right? So, getting into this topic, this is something that my long history has been always with firewalls and different implementations of firewalls, security products, building kind of a security architecture altogether. This is what I've been doing in my recent history before I came to F5. And in all of those cases, it was always the discussion about the security features, not about the SSL, not about encryption, not about hashing so much, unless you talk about VPNs. F5 has a pretty long history with SSL. So if you are an existing F5 user, you know what F5 is. We did our own SSL stack back in 2001. So it's been a rather long time there. It has nothing to do really with OpenSSL, for example. If you remember year 2009, OpenSSL, that was a big disaster altogether when it came down to SSL. Commercially, we are pretty big in ADC. And what we do in ADC business is about kind of offloading the tasks in there. So, but it has grown. And SSL, TLS 1.2, for example, and 1.3, that is a big thing. They require multiple things. The bigger thing is the cipher diversity. Think about how many different ciphers, how many different hashing algorithms are out there. You can make your own combinations when you do your site, when you do encryption. It's not that easy that you say that I'm decrypting SSL. Okay, there's the different types of SSL. How do you do authentication? Are you doing per user smart card authentication? Are you doing let's say, HTTP header certificate pinning? Are you requesting the browser to be able to see the original key that is being presented by the server to possible decrypting entity in there? There's a lot of caveats there that you need to understand. But when somebody says that they do SSL or TLS, it's not that straightforward altogether. So very important thing is that you support all different ciphers, all different ways to do the encryption, encrypted connection, handshake. That's the thing. Nowadays, Google is using TLS 1.3. If you use Cloudflare services for CDN, they use TLS 1.3, which is not generally otherwise supported. So it comes down to questions, to ask the real question, what is being used as cipher? What is being used as a certain function? Then when you do encryption, decrypting and re-encrypting, it's really, really CPU intensive task. So if you try to do that with virtual machines, you need to have a lot of CPU power. If you do it on dedicated hardware, you need to have dedicated hardware that can support different ciphers. Then it comes down back to the cipher device diversity that's being used there. So in our logic, we have always implemented into the ADC dedicated chipset that is taking care of the encryption. So own CPU that is doing that. Historically, we have also made mistakes in there. We used to use KVM implementations, and at some certain point, KVM CPUs had their limitation that you couldn't do ECC calculations, so ECDSA generated keys. So when you go to elliptic curve, it's pretty tricky thing to do compared to the kind of RSA-based keys. So it comes down to more into complexity of things. In history of F5, we have been doing all of this. It's been part of us almost since the beginning. And this is something that is developing there. But getting into the actual use case, this is what we've been doing since 2001. So when traffic is coming from outside in, we are presenting the trusted certificates and building the SSL connection towards the client. And because we are full proxy, there might be connections that are totally unencrypted that go from outside in. But this is not really the topic of today. If you do this has been always available there. And a lot of people that really kind of think about the architecture, for example, what Lohenoja is talking about right now about architecture approaching a different track where you are not obviously in, but he's talking about the architecture thing. And by doing these kind of implementations, you can actually send the traffic to security devices and they can see. The bigger problem nowadays is the SSL visibility. When you do implementations of encryption using services, and your users are using encryption services or encrypted services, this is pretty tricky. You can say, this is something that, by the way, this is something that you can say every year. Unprecedented year, it's pretty much every year in security. Nowadays, you just have to announce your mistakes. You have to announce that, oh, by the way, we got hacked. Oh crap. How many of you have ever been in a site called Have I Been Pawned? Yeah, go there. Have I Been Pawned? Go to Google, look it up. You will see how much you have been already fucked, so to say, in there. You are already in a deep shit when you go into that. You can realize that your email address has been pretty much leaked, and in some cases your password has been already leaked by Dropbox and LinkedIn and maybe Adobe. If you use the same password in every service, you're pretty much screwed right now. That's a different thing, but remember that that's something that's there. Nowadays, cybercrime is going after identities, usernames, passwords, credit card numbers. All that has a value, but it's a low value, so you need to get a lot of those. So if you get username, password, it's about $8. So if you get, let's say, 1 million user accounts times 8, that's a lot. Or even if it's 100,000 of those, that's a lot. Then you can convert that into crypto value, and there you go. Look at the value of Bitcoin, for example. This is where it's going. So every data breach nowadays happens in a different way. The most common way of doing this, unfortunately, it's totally black, so I'm skipping the crazy animation in the process. But the whole thing is that you have always attackers. They have one sneaky way to get malware or something other suspicious into users' laptops. And then the user laptops, user devices, nowadays IoT. If you look at the Mirai bot network, that was totally IoT and is totally IoT. That is generating a hell of a lot of traffic. And a lot of those ways how the malware and all the suspicious activity can be done is through cryptography. So you are actually encrypting traffic that is coming from the malicious entity to your services, to your platforms, and then they do something nasty. The fact is that a lot of companies have invested already to security. There's forensics, there's next generation firewalls, there's you have secure web gateways, you have IPFs, you have different data loss prevention implementations if you need those. But more importantly, you have mail gateways, anti-malware solutions, which don't generally decrypt SSL or TLS. Or if they were able to do it when you purchase that, they don't track down the development in encryption. So nowadays, even, well, this year, the promise is that we will get TLS 1.3. When that one comes out, each and every vendor, if they ever gonna support that, are gonna release that in a different cycle, and it might not even happen. For example, all forensic boxes nowadays, they don't do any decryption. So, and if they start to do it, you need to buy a bigger box because it's very CPU intensive. And the story goes all around this. So why not to do this in a smart way? You should kind of do it anyways, because normal incidents detection is around 6 months or more. So if you look at the Mandiant Labs information on this. Nadia is saying that in 2015 and 2016 report that the median number of days before detection is around 205 days in a breach, which means that you have 205 days to transport data back and forth, back and forth. And what is scary in here is the GDPR. So what happens right now in, I don't know, all around is that there's attacks. There's a lot of malicious stuff going on, which is not being stopped by the traditional infrastructure that you have, because it's not able to see. As far as it's able to see, it can stop. But when you go into encrypted traffic, it flows through like there was nothing between there. And what malware is using, what all the malicious activity is using, they use the best cryptos because they know that there's a big caveat in this one. So this is the blind spot. Nowadays, all, like if we look all internet traffic all together, it's about 70% is encrypted. But if you think about the services that you use as a person, how many of those are encrypted? How many times you go to internet banking? How many times you use YouTube, Google? All services generally that you use are SSL protected. There's TLS 1.1 or 1.2 in those services. When you have your security device in your network, if you have like gateway security, what is the application that it sees? HTTPS. It can detect the user and it's HTTPS. But what happens in that tunnel? It's like having a VPN there. So the blind spot, if you don't do any kind of decryption or selectively even try to decrypt the traffic, you have a really big blind spot. Let's think about that you spend 100,000 euros to a firewall that has all the gimmicks in it, but then you can only see 30% of traffic or less. How was your investment? Let's think about that business-wise. That's kind of hard to explain, that's why there's a lot of crap going through that. So you really need to do something there. And what NSS Labs, when they were testing this, they realized that there's a big caveat in the performance of devices. Security device, this is something that should be really, really considered heavily, because it's up to the question how much risk you are willing to take. Because among the all encrypted traffic, all the good stuff and bad stuff is going there. And going back to the GDPR discussion, there's a lot of discussion in the internet where there is data breaches done right now. Then the data is kept as hostage closer to 2018, May. What happens then at the end of May 2018? Everybody has heard it. There's the GDPR, and there's certain things. There's the finding step over there. So what does it stop anyone to capture data right now, then present the proof of data in May 2018, ask for some crypto value, and otherwise I will tell you that your data was breached to EU GDPR auditing parties, and it's going to be more expensive for you. This is what's going on. That's, if you want to do, you are not stupid if you get into that. So you need to be really smart to actually be able to pull it off. But right now it's really easy when you have a lot of encrypted traffic. Malware goes there, visibility goes down if you don't do anything. And in security devices in general, if you do something to SSL, it will affect the performance. Every one of you who have ever worked with firewalls and security devices, more you have features in there, more it will affect the performance, no matter what is being said. The data sheet is one thing, and then the practical thing is the other. So where actually to move their workload? NSS Lab has pretty good report on the effect of the SSL traffic to security devices. If you really want to do it, then it will affect the performance, and you need to buy a really big box. That's kind of the minimum thing. Then the other thing is that the security devices, well, going one step back, the security devices, think about this. If it's a firewall, if it's an IPS, if it can decrypt the traffic, it will only decrypt the traffic for itself. Then it will encrypt it again. If there's other device, it will have to decrypt it again and encrypt it again. That will cause other kind of issues, thinking about latency. So what we do, we presented some time ago option to use F5 as SSL orchestrator. So when traffic is coming in, we can interrupt the session by building one session between the user and the orchestrator, and then with the our orchestrator and the application. So leveraging the full proxy capabilities of F5 to build SSL forward proxy capability into that. So you can make policies where you select which traffic will be interrupted, which traffic will be decrypted, and which security devices will get, in different cases, the traffic. This was the initial architecture picture that we had, where we presented the capabilities to SSL visibility. This was our vision, to have one centralized device that will handle all encrypted traffic and then selectively control the path where the traffic will end in different use cases. So if you have normal internet browsing, how to handle that? If you have mail traffic, how to handle that? If you have backup traffic, which security devices need to do that? If you have read into the cloud world, there's the service chaining concept over there. And that's what we are looking after here. So what the SSL orchestrator really is, what we do, it is to take care of the decryption of the traffic, do different kind of deployments accordingly, because there's a lot of traffic that just passes through the internet directly to the service. Of course, that you cannot decrypt, but you need to kind of deal with the issues of the modernized world over there. But you can build the visibility, you can build that kind of deployment that you actually need, and then you can start building those service chains. And service chains, on the other hand, allow you to do really smart security implementations, which you cannot really do unless you do policy-based routing. And everybody knows how fun that is. If you have ever done policy-based routing, that's fun. There's a job security in that. I can guarantee you that. So once you are able to do that, it's like, whoa, nobody else can understand. Even if you document that, it's like, oh shit, it's like way too complicated. So what the policy-based dynamic service chaining is that you can build classification engine. For different cases, you can detect by packet where the packet is coming from, where it's going for, according to URL, IP address. There's the IP intelligence database. So how, trusted the direction is where it's going. So if it's going to a Tor network, if it's going to anonymous proxy service, should it be decrypted before it gets there, or if it comes back there? So if you really want to build security according to what you know, what's the intelligence that you have, what do you know about the user, what do you know about the traffic, it's very easy to build security according to IP intelligence, because then you have knowledge, what is possibly malicious, what is possibly not malicious. Then there was question in the Juniper session that where is our IP intelligence coming from? It comes from web root, it comes from F5, it's a combination of multiple things. If you have your own source of IP intelligence, you can use that. So if you have already purchased some feed from Riot Cloud, for example, or somewhere else, you can decide what you want to use there. But then you can build chains. Chain 1, chain 2, chain 3, chain 4. How many you need to have to do implementation. And if you already have security devices, you can decide which one you want to use. So if you have multiple security services altogether, you can decide which one will get the traffic in different use cases without doing policy-based routing. Cool. So we have already made some partner solution guides. So if you have Cisco, FireEye, Symantec, ECDSA, Palo Alto, Checkpoint, Trend Micro, there is implementation guides, how you can implement those as part of the chain. But the configuration process is really easy. So you can decide, do you want to do single box design where there's a one F5 device. It might be SSL Orchestrator, or it might be just a big IP that you might already have. Or you can make two box implementation. So one is decrypting, one is encrypting when it's going from inside out, and when it's coming back, this one will decrypt and this will encrypt the traffic. The performance hits, according to datasheet numbers, is lower when you have two devices. If you have one device that will decrypt and encrypt everything, it's about half of the datasheet numbers in those cases, what you can do, because one half is going for the encryption and the other half will go to the decryption and vice versa. So this is important. How do you get the traffic there? Routing, policy-based routing, and VCCP. Those are the main things that you can use to trick the traffic to pass through this process. Then you have option to send the traffic over L2, over ICAP. So if you have security devices that want to use application protocol for it, well, reduced HTTP, that's called ICAP. L3, routing, or receive-only devices. And it's really, really easy to configure, which is the funny part. So configuration process with really big features altogether is to define which security devices you have in your environment. Then how do you want to change those security devices for different use cases? And then you build the policies. Every packet that will hit the F5 orchestrator will be evaluated according to the values that you give there. And then it will select which chain it will pass through before it will be re-encrypted. Every time that it will hit this, it will be decrypted traffic all the way through the chain, and then your security devices will definitely see what is in there. Of course, I said already that not everything can be decrypted. This is a topic that you need to understand. Banking traffic, no. Healthcare, hell no. Private email services, well, depends on your local policy where the traffic is passing through. There's a lot of policy-based things that you are not allowed to do, or legal-based things that you are not allowed to do. So you need to recognize what you can really do and what you cannot really do in those cases. And when you do the configuration, then you need to recognize services that are HTTP header in, like Windows Update, Apple Update, and Android Store, services that are not allowing the traffic to be decrypted. Internet is full of those. So if you go to Google, HTTP header certificate pinning, read the documents. You need to understand that, because then we get to the tricky part of decrypting traffic. Doing this kind of configuration and implementation, that's simple, but you need to understand the legal aspect of things, technical aspects of the things, and then policies that your company has implemented. Then you can get into the GUI and start doing the easy stuff. This is way, way simple, more simple than you would think. But the whole logic here is that we take off the load that your security devices would have to do. There's a question.
Yeah, there's a question about, okay, the certain traffic cannot be decrypted, but how do you define these categories on the device? Do we have this, ability to define that, for example, healthcare traffic is not being decrypted and forwarded to someone?
That's a good question, really good question. There is actually URL category filtering that has the information of healthcare services, banking services, and so forth. And this policy is as good as the source where we get the information from. Then the HTTP header certificate pinning services, we have a list that is updated constantly in every SSL orchestrator that knows all the known services that use HTTP header pinning. For example, Dropbox, you cannot decrypt. If you want to see what is in a Dropbox, you need to go through the APIs, and then it's business of cloud access security broker. So then you need to have a task for that. So there's always a different solution. This is not solving everything, but this is solving the issue that you can see as much as you possibly can see.
But do you have these URL categories in your device that should be a third-party box?
The URL categories that we have our own feed, plus we use the ForcePoint database for it. ForcePoint has pretty good database for it, but Of course, if there's something that is missing from there, it has been so far only a couple of hours and it's been updated in the database. So fair enough, every country has their services that are not understood as healthcare. For example, Finland has Mehiläinen. Mehiläinen is kind of a private doctor clinic service, what is using kind of doing different things related to healthcare, but that wasn't in the database. Getting that in there, that was 30 minutes. That was one ticket and complained that that wasn't there. 30 minutes later, it's there. So, of course, there's always, it could be better, but it's not a major caveat.
Yeah, but once again, this URL category, you have one on this box, but if you are talking about using a WebSense or ForcePoint URL categories.
Well, they use their own services, but we have deal with them. So inside the box, there is the ForcePoint.
So you can subscribe.
Yeah, we have it. We have ready-made deal for it.
Okay.
Or if you have your own feed, you can also use that.
Everything can be integrated.
So you can do iRules, you can do TCS scripting and implement your own feed as well. If you have your own SOAP, for example.
Okay.
The major thing here is that when you do configuration, it's all graphical, it's nice and simple to understand. The thing that has to be understood when the configuration is being done is to understand the chain that will be done, what you want to decrypt, why you want to decrypt. This is not that try to decrypt everything. This is that you define what you want to decrypt. It's not that it will try to decrypt everything. You will define the policies that will be decrypted. The most stupidest thing that I have ever seen and heard is that when the device tries to decrypt everything, what will happen to most of those services now when you know that it's technically very tricky and also policy-based, very tricky? There's a lot of services that will break down, and how are the users after that? Not very happy, right? Normally you get the call, you get the ticket, you get something, you get a lot of nasty stuff after that. If the internet doesn't work because somebody tried to do something that wasn't kind of smart thing to do. That's why the service chaining is a really powerful tool over there. And you have a lot of options. You can use geolocations, you can use IP addresses, you can use the URL categorization filtering. And that is something that is very defining factor. Also, are you doing it in L2, L3, or somehow otherwise? So that's something that is really, really cool in this implementation. Then you have possibilities. If you want to have F5 that is only dedicated to do this, you can buy a white version of F5 that is called Herculean nowadays. Last year, somebody in the marketing decided this is a good idea, so let's not have black boxes at the F5, but let's call the white boxes Herculean. In Herculean, there's possibility to buy F5 that's only dedicated to do the decryption of the traffic. And in that implementation, it only has the capabilities to do the SSL decryption, service chaining, and so forth. Implementation-wise, it doesn't differ from any other F5 at all, except it's white, and it has some dedicated capabilities and GUI that is only enabling you to do this one thing. And you can never update that to be full-blown F5. If you want to use it as a load balancer, big no. If you want to use it as WAF, where we are really good at, no. If you want to do any other stuff there, answer is no. You only decrypt traffic with this one. Or if you have F5 already, you can buy big IP and do WAFing, you can do the SSL decryption, federation services, and so forth. But if you want to just do one thing, that is the traffic visibility, then it's this one. The new I-series boxes, which this is also based on, they have Altera chipsets that are reprogrammable. So every time that there's a new encryption algorithm, hashing algorithm coming out, we can push new code in there and do it on hardware. So not to have the KVM defeat, the KVM issue that we had before. So always the big question when somebody's talking about decrypting SSL, how do you do it? Are you doing it in software or hardware? Which kind of hardware you have? That's a big thing. Otherwise, we are full-blown Intel house at F5. So all our components are generally Intel. Altera is nowadays also part of Intel. So we didn't know that when we went there. So Altera was best in business and then Intel bought it, trap. that happens. Technically, I promise that this is more technical track. It will give you nice dashboards where you can actually see analytics, what was the incoming and outgoing encryption algorithms, what algorithms were used in different services. All these slides will be available after the event, so I sent those to local Santa Monica people, so you should get these slides. Hopefully, you can ask them from there. If you don't get them, you can go and see how this is going. But this is actually breaking down what was used in the client side, what was used in the server side. So you can see which kind of traffic services are being used out in the internet. Nobody has actually asked big questions in here, so I will ask those quickly and answer those. Going back to bigger picture, what is the certificate presented to end user? The one that the end user is trusting. So it might be locally trusted certificate. How do we check that the applications in the internet are having valid certificates? We have CA bundle that has been extracted from Chrome and Firefox. And those are supposedly very up to date. If they are not, then we are not up to date. Sorry. So we need to take care of the PKI. This has to be valid, solid connection where there's dedicated encryption keys, dedicated algorithms in place, and same thing to the outside world. So this use case is from inside out. What Jani was explaining here before I came here, to get all that working that Jani was explaining, you need to also deal with the encrypted traffic. You need to have SSL forward proxy in place in some form. And the smarter the forward proxy function is, more you can do the service chaining and implementation. All this that we do, it's over 20 years old as an implementation. So it's been there, it works. A lot of your services, out of those services that you go and use in the internet, they use F5 as the ADC to present the certificates and do the SSL for you. So it's more about testing. So if you want to test this, you can get virtual machine from me, and we have also dedicated devices if you want to use hardware testing. And when you do testing, then you can verify how crappy service encryptions are actually being used out in the internet. A lot of servers are going with lowballing the encryption, and those ones who want to get into the first page of Google, they have the best encryption because Google is evaluating the encryption being used in a service. To get A+ in SSL labs might mean that you get the first page of Google, and that's kind of a big thing. How often do you go to second page of Google? There you get the answer. A lot of people don't go there. You can hide a body in the second page of Google search things and nobody will find it ever because nobody ever goes there. So that's pretty much it about the different visions and things that can be done there. The main takeaway here is to remember that the encryption is not a simple thing. To do security, you need to see inside the traffic. If you have an issue that you buy the best security device in the world, it has to be able to deal with the encryption. If it's not able to do it, then you need to have somebody else that will take care of it. And keeping up with the encryption algorithms and way how the world is going, that is very important. It's also important for you to understand how the encryption works. It wasn't like that unless you dealt with VPNs for a long time. Now, there's a chance for 2 quick questions.
Not really quick, pretty heavy.
Okay, one.
Let's imagine a situation you have a client making connection to your server behind the SSL offload device.
Yes.
Session is done, and this session is being uploaded to some third-party malware inspection device.
Yes.
It's a clean session, so malware device can check all this, stuff
Yes.
what's going on. And it finds one packet is malicious and it killed it.
Yes.
How does the situation be presented to the end user on the other side?
For the end user, there will be session reset, but then you can send also either a web page that will explain what happened there.
So F5 device will take care
Yes.
about this and present the situation to
Yes.
the other side that sorry,
That is
packet
correct.
was killed.
That is correct. It works with Palo Alto, it works with Trend Micro, It works with FireEye at the moment. There's already made an API implementation of that. If you want to customize that, you can customize it as much as you want. And if you're a very skillful guy, like you probably are, then you know that you can do APIs and kind of read more information out of the box. So if you want to extract more in the malware detection device, you can use the APIs, which seems to be the case in most of the vendor cases that they have open REST API. And that's what we leverage as well. We use the APIs to discuss with the other devices. Not so much IP traffic, but it's generally the APIs. Of course, over IP, but it's not just a certain packet that it will send back, but it's integration into API. There's a lot more into that. There's a lot of depth into that. Checkpoint, Palo Alto, Cisco, everybody works a little bit differently in there. So, load balancing. So that was the first use case that we have pretty much ever made. So load balancing is based in the different algorithms. So in this, you mean in the SSL offloading case. There we leverage the underneath LTM that we have in F5. So then you can decide if you have multiple different security devices at the same time. For example, Cisco SourceFire devices there. Then you can define the pool which device will get in different use case over there. It's exactly the same way of configuring the load balancing as it is, as it is in the LTM. So it's a core function of F5. So then you can detect which device is online and which one is not online. You can build monitors also for those in the same way as the LTM. So that's the 20 years old core function of the whole operating system. That's very easy to do. So if you have multiple Palo Altos, multiple Cisco's, multiple checkpoints, you can balance also between those. That's possible. Good question. Anything else? Marco wants to, I think Marco wants to, yeah. If you want to.
I mean, yeah. In the case you will come up with some other questions further on, please come and visit our booth. We are over there all day.
Yeah, and if you have more into this or something else, then please come and ask. So, I guess it's Marco's turn.
Thank you.